Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 6.4 directed line segments. What will we be learning? Well, by the end of the lesson, you will be able to find the coordinates of a point that is a fractional distance of a line segment, much like we did with midpoint formula. The only difference is with midpoint formula, we were always looking at a middle point or 1/2. Now we are going to be looking at fractional distances that are not as simple as 1/2, therefore making it so we really can't use the midpoint formula. Well, why do you need to know this? Well, so that you can apply your knowledge to things like force and velocity, which both involve magnitude and direction, and can be represented by a directed line segment. How will you know you've mastered it? Well, you'll know you have mastered it when you can correctly find a point on a directed line segment between two given points that partition a segment into a given ratio.
Very exciting.
I know.
So let's get started. First, what does partition mean?
Well, partition, part, is the root word in partition, and a part means to take a piece of something or a piece to divide into parts.
Mrs. Netz, what's the difference between this and bisect?
Well, bisect means we are cutting in half. This is partition, which means we are breaking it into a part.
So it doesn't have to be in half.
No, it does not have to
So
be
you're
in
just
half.
breaking into pieces, not necessarily in half.
Yes.
Got it. All right, next, what is a directed line segment? It is a segment that has magnitude, which we know means distance or length of something, and direction. So we kind of did this with vectors.
We did do this with vectors.
So if you remember.
Vectors and directed line segments are very similar. They have many like qualities. They are not the same, but similar.
They represent different things, but at this level, I feel like you guys can kind of think of them as the same thing. You're going to have an initial point where you're going to always start, and you'll have an end point, which we know we called a terminal point when we talked about vectors. So you're going to have a starting place and an ending place, which gives you the distance and direction in which you are having to move.
Now, this is very important because understanding that you have a start and an end is very important, because with directed line segments, it's there's a direction, which means the order of our points matters. So please, please, please read directions carefully and make very close notes and bring close attention to which letters are first and which letters are second.
So looking here, this is what Mrs. Ness was talking about. So far when we talked about line segments, it didn't matter how we named it as long as we used the two endpoints with a little dash over the top. Well, now that we're talking about direction, we have to go in the order that the letters are being named in. So if you look here, we're told to look at segment AB. Well, that means our initial point has to be A and our terminal point has to be B. So looking here, you can see that A to B, it's asking what is P splitting this segment into? Well, if you look, we have 1, 2, 3 pieces before we get to P, and we have just one piece after P. So we would say that this is a 3-to-1 ratio.
Now, a 3-to-1 ratio is the same thing as saying the scale factor would be 3/4. Now, how do we get that? Well, think of it this way. When you're talking about a ratio, you're talking about part to part. How many parts do I have on one? How many parts do I have on another? When you're talking about scale factor, you're talking about a part to a whole. So when we're looking at scale factor, the part we are talking about in this case would be 3, and the whole piece would be 4.
Because 3 plus 1 is 4. Okay, let's go ahead and look over here. I'd like you to pause the video and see if you can come up with the ratio and scale factor for the segment on the right, still being called AB. Okay, so hopefully for this one you came up with a ratio of 1 to 3, because you have just one segment before you get to P, and then there are 3 after from P to B. which would give you a scale factor of 1 to 4, because again our total is 1 plus 3, giving you a total of 4. Okay, so let's go ahead and move on to the next. If we are given a graph and you are asked to find the directed line, or the point that splits a directed line segment into a given ratio, here are the steps that you are going to need to follow. The first thing that you're going to need to do is write the given ratio as a scale factor. So that step goes back to what we did back here. So we were able to see that this was a 3 to 1 ratio, which was a scale factor of 3/4. Over here we had that 1 to 3 ratio, which was 1/4 of the total. So we would go ahead and do the same thing. Given a ratio, we would convert it into a scale factor form. The next thing we would ask you to do is find the slope of the directed line segment. So from the first initial point to the terminal point, what is your slope? Little piece of information that I would definitely add here. You're not going to hear this very often. Do not reduce that slope. Do not reduce slope. Again, you're probably never going to hear that again from a teacher. Don't reduce that fraction. You don't want to see it reduced because you have to keep that distance piece. So if you're going up 4, right 6, you don't want to cut that to 2/3 because you want to keep that distance of 4 and 6 as part of your problem. The last thing you're going to do is you're going to dilate that segment from the first initial point. So you would use that scale factor and the slope and combine them through multiplication, just like we did in our lesson 6.1 with dilations. Once you've done that, you can go ahead and go from your initial point, apply the new slope, and you get your point P that partitions that line segment. Let's go ahead and do one. So our first step was to take our ratio and convert it into a scale factor. So my ratio here is 2 to 3. Well, the 2 is the number that we're going to keep. Our scale factor goes over the total. Well, if we have pieces of 2 and 3, the total would make 2 over 5, because 2 plus 3 is 5. Our second step was to calculate our slope. Well, the segment name is EF, so that's giving me the clue that I'm going from E to F. So I need to rise and run from E to F. And it's going to be rise 5, 1, 2, 3, 4, 5. And then I'm going to run 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our third step is to now apply that scale factor to the slope. So 2/5 was my scale factor. My rise is 5. So I need to figure out what 2/5 of 5 is. Well, if you multiply those, the 5s are going to cancel and you're going to be left with 2. Next, same do with the run. Well, I need to figure out what 2/5 of 10 is. Well, 5 into 10 is 2, and 2 times 2 is 4. So 2/5 of 5 is 2, and 2/5 of 10 is 4. So I'm going to now go from E, I'm going to go up 2 and right 4. So you can see right here, I have the triangles under here just so that you can see them more visually. But if I went up to 1, 2, and right 1, 2, 3, 4, you can see that I'm landing right here on this point, which is at a -1, 1. And that is the point I'm looking for in this problem. That's the point that partitions my line segment into a 2 to 3 ratio. All right, the next problem is another example of the same type of problem. So what do you say, Mrs. Nets? Should we let them try and do this one?
I think they can do it.
Okay, so the only thing I'm going to say is step 1 is done for you. Step 1, it's asking you to, that should not say into a ratio. The factor is 1/3. Here's where I was going with this. Sorry, so I'm going to go ahead and fix that right now. The scale factor you're using is 1/3. So step 1 is done for you. So go ahead and work through the rest of this. Find the slope and apply the 1/3 scale factor and figure out where point P would lie. That would be 1/3 of the total.
And if you get lost, just turn back and look at our previous example.
Okay, so the next thing you should have done is calculated your slope. Hopefully you caught the name of your line segment is AB. So hopefully you went from A to B. You didn't go B to A. Hopefully you caught that. You should have gotten a slope of down 6, left 12. Remember, I said do not reduce, so hopefully you left this as negative 6 over negative 12. Your third step was now to apply that scale factor of 1/3 to your slope. So 1/3 of negative 6 is negative 2, and 1/3 of negative 12 is negative 4. So from A, you're going to go 1, 2, 1, 2, and then left 1, 2, 3, 4. Right there, that point at 3, 2 is the point that is partitioning into a 1:2 ratio, or 1/3 of your total.
Now, one thing that I'm sure could be causing some of you some confusion right now is we know that when we have a negative over a negative, that's a positive. So this negative 2 over negative 4 that we have found when we did our slope of AB and then multiplying it by the 1/3 when we had negative 6 over negative 12. So you're right, that is positive. And if you look at the actual line segment that we are investigating or partitioning or getting a segment of, you'll notice it has a positive slope. So the reason we want to keep our negatives is you have to remember that the negatives tell us a direction. So by saying negative 2, we know that we need to go down 2. And negative 4, we know we need to go back 4. This is helpful because we are starting from point A. This would have us all kinds of messed up and lost if we had started at point B, because then we'd be cutting something that's not there.
Exactly. So that's why I said don't reduce. You don't want to take those negatives off either, because it's giving you the direction and distance piece. All right. Now, what if we don't have a graph? You could graph always if you have graph paper and can access it. That is one way you can do it, but a lot of you prefer formulas, so there's also a formula we can use.
Did you know that the section formula is the midpoint formula?
We're going to learn that now, hopefully.
It's kind of weird.
It is.
Like, if you really look at it.
So, as we talked in the beginning, midpoint is a directed line segment in that it is splitting a segment in half, which means half is my scale factor, which means my ratio is actually 1:1, piece to piece. Well, if you look at this, our section formula is partitioning a directed line segment into a ratio that is m to n. Right here, m to n.
Or part to part.
Or part to part. Well, in a midpoint, our parts are 1 and 1. Well, what's 1 times x1?
X1.
And what is 1 times x2?
X2?
So what we have on top, if our m and n are 1s, you're left with just an x2 plus an x1. On the bottom, you're adding your m and n. Well, what is 1 plus 1?
2.
And there's our midpoint formula.
Wow, so you could actually go to your midpoint formula and you could actually put your m and n in there, which is 1. So I could put 1 times x sub 1 plus 1 times x sub 2, and then do 1 plus 1 in my denominator, and I have
You have it.
midpoint.
There you go.
Cool.
Very cool. So how are these two formulas the same? I have just a sentence here. You can put this in your own words, but it's basically what we've been talking about the last few minutes. The two formulas are the same. The midpoint formula has a ratio of 1:1 and a scale factor of 1/2. So your m and n are 1 and 1. All right, so we're going to go ahead and use the formula now. As we always like to see, please write down the formula. You're just going to copy it down.
Now remember, you're always going to write this down almost like it is a coordinate, where you've got everything about x before the comma and everything about y after the comma. So you're going to have x is over on the left and y is over on the right.
So the first thing I'm noticing is my ratio. My first letter is 2. MN, it goes alphabetical, so it's always going to be given to you in that MN order. So wherever you see M, which are in these 4 places, you can go ahead and plug in a 2 there. I don't know why the color doesn't change for me. All right, wherever we see N, which are in these 4 places, it's going to be a 1 that we're going to plug in.
I would highly recommend every time you start one of these problems, when you go to set it up, immediately do this first. So that way, all you have left to do is just substitute in your X values and Y values.
If you look here, the name of this segment is AB. So that is telling you that A is your X1, Y1. Right there. Your B is your X2, Y2. I think I got my colors backwards with what I have typed. Sorry, I'll have to fix those. All right, so notice where your X1, Y1 are. They're at the end, so it kind of goes backwards. And then for your X2, Y2, they go in the beginning. So what we're going to do is simply plug in all of our numbers. Knew it. I got my colors backwards.
I think everybody will be okay.
I hope so. Sorry about that, everybody. There we go. So I plugged in my M's, you can see in pink. So the 2 is our M. You can see I have that in those 4 places. 1 is our N value, so you can see I have it in those 4 places. And then 6, 1 is our X2, Y2. And negative 3, 4 is our X1, Y1. After you've done that, you're literally just going to start simplifying. Know your order of operations. On the top, you have some multiplication you have to do. It's going to be 2 times 6 and 1 times negative 3. You have 2 times 1 and 1 times 4. On the bottom, you have some addition. 2 plus 1 and 2 plus 1. So that's going to simplify to this. 2 times 6 is 12. 1 times negative 3 is negative 3. 2 plus 1 is 3. Over here, 2 times 1 is 2. 1 times 4 is 4. And 2 plus 1 is 3. Now in your numerators, you have some simplifying to do. We have 12 plus negative 3, and we have 2 plus 4. That's going to give us 9 over 3 is 3, and 2 plus 4 is 6. 6 over 3 is 2. So the partitioned point is 3, 2. And that's all it is. I know the formula looks scary, but hopefully you see you're just plugging in a bunch of numbers and you go from there.
And then if you really just immediately write down your M and N values and then substitute in your X and Y's, you should be fine.
Yep. All right, so you have one more problem to do. Would you like to try it?
I think we should let them try on their own.
So make sure you look at the name of the segment. All right, so first thing you guys should have done is written down your formula. And then again, kind of look at the clues that we're giving you. We know that M is 3, so we should have put a 3 in those 4 places. We know that N is 2, so in these 4 places, you should have written a 2. The name of our segment is BA, so that's telling me that B is our first point this time. So this is our X1, Y1. And A is our X2, Y2. So it's backwards.
Now, one of the things I did in my notes, just to help me keep things straight, is right above my coordinates, I wrote which was coordinate set 1 and which one was coordinate set 2. So in the actual problem, right above 8, 9, I wrote the number 2, and right above negative 7, 4, I wrote a small number 1. So that way I know which number came first and which number came second.
So what you should have is something that looks like this. And then from here you should have just started simplifying. 3 times 8 is 24. Negative 7 times 2 is negative 14. 3 times 9 is 27. 2 times 4 is 8. On the bottom you have 3 plus 2 on both of them, which would give me 5. Next you are adding the... So now you're just going to do division. 10 over 5 is 2, and 35 over 5 is 7. So the point that partitions BA into a 3-to-2 ratio would be 0.27. And that is the conclusion of directed line segments. Hopefully you feel confident about both doing it on a graph and using the section formula through a little practice.
When you go to do your homework, it will help sometimes to draw some pictures, especially when you are given points. What you may want to do is just draw a line segment and label it A, B, C, or whatever the points may be. That way you can just kind of see what's going on. That'd be a little helpful
Hint,
or
there you
tip.
go. All right, if you have any other questions, as always, reach out to us.
Hey, Mrs. Weichel.
Hey, what, Miss Nets?
What did the evil fraction say?
Uh-oh, what?
You will never stop my plans for world denomination.
That evil fraction. All right, we will see you in 6-5.